Now we know that it is the vibration that produces the sound. We hear so many different types of sounds in our daily lives. What is it that differentiates them? What separates the different types of sound? It is the frequency and amplitude. Any sound that you hear has some amplitude and frequency. If you change any one of them, you will hear a different sound. But what do these terms mean? Amplitude determines the loudness of the sound, and the frequency determines the pitch of the sound. Let's discuss this in detail. The number of times in which same thing happens again and again in a given period of time is what we call frequency. Let me give you a simple example. There is one bus which arrives at this bus stop every 5 minutes. So we can say that the frequency of buses on this route is one bus every 5 minutes, or say 12 buses every hour. Let's move on to a slightly more advanced example. Suppose we have a pendulum here at the mean position. When it is set into oscillatory motion, it will start to move right and left from its mean position. When can we say that it completes one vibration? Let's look at it in a slow motion. It completes one vibration when it moves from mean position to this point, which is towards the right, and then crosses the mean position to this position, which is on the left, and finally back to mean position. Yes, that completes one vibration. We need to understand vibration well. It's initially at the mean position, goes right, goes left, and then back to the mean position. That's one vibration. How many vibrations does it complete in 1 second? The answer to this question is what we call the frequency of vibration. Yes, frequency is the number of vibrations or oscillations per second of an object when it is set into oscillatory motion. It's measured in hertz and is written like this. How can we define 1 hertz then? 1 vibration per second is defined to be 1 hertz. So if this pendulum vibrates 2 times per second, what will be its frequency? It will be 2 hertz. Similarly, if it vibrates thrice per second, its frequency will be 3 hertz. But wait a moment. We are talking about sound only. What is this pendulum doing here? We know that it is the vibration of any object that produces sound. So pendulum oscillating here must also produce sound, right? But we don't hear any sound coming from it. Why can't we hear the sound? The reason for this is that the human ear can only detect frequencies of sounds greater than or equal to 20 Hz. We will study more about this in the future videos. Here, the frequency of oscillation of the pendulum moving to and fro is simply too low for us to hear the sound. We've said earlier that frequency defines the pitch of the sound. But what is the pitch of the sound? Pitch is that perceptual property of sound which helps us to identify whether the sounds are high or low. Yes, it's something that is just perceived. Say we have a piano and we are looking at this set of keys. Press the keys on the left-hand side and then a key on the right-hand side. Do you see any difference in the sound? The sound from the keys on the left is lower and the sound from the keys on the right is higher. When we press any keys on the left side, we hear the sound of the lower pitch. And when we press the keys on the right side, we hear the sound of the higher pitch. Why does this happen? It's because inside the piano, the string inside is vibrating with lower frequency when we press the lower end keys. And it vibrates with higher frequency when we press the higher end keys. More the frequency, higher will be the pitch, and lesser the frequency, lower will be the pitch. One important note here. Don't try to relate high and low sounds with loudness of a sound. They all are different. Louder sound can have a lower pitch and comparatively less loud sounds can have higher pitch. For example, a chalk screeching on a blackboard has a high pitch, but it is not so loud compared to the sound of drum, which has a lower pitch but comparatively high loudness. Now let's talk about amplitude. We take the example of a pendulum. In each vibration, it covers some distance from the starting position. This distance decreases with time and eventually the bob starts vibrating. The maximum of this distance is called amplitude. Yes, the maximum distance travelled by a bob from its mean position is what we call as the amplitude of vibration. So in this case, this distance will be the amplitude. Note here that the distance we are measuring is from the mean position and not from anywhere else. Instead of a pendulum, now if we take a tuning fork, then can you tell me what will be the amplitude of vibration of a tuning fork? Yes, its amplitude will be the maximum displacement of its tines from the mean position. When we vibrate the tuning fork, we hear the sound produced by these vibrating tines. But what will happen if we vibrate it with more force? We will hear louder sound. You see that the tines are vibrating with larger amplitude. Here's an interesting thing. More the amplitude of the vibration, more will be the loudness of the sound. Yes, so if tuning fork vibrates with high amplitude, its loudness will be more. So if a sound is loud, it implies that it has higher amplitude. And if a sound is feeble, it means that it has comparatively lower amplitude. In fact, the loudness of sound is proportional to the square of the amplitude. If the amplitude becomes twice, the loudness increases by a factor of 4. If amplitude is 3 times the original, loudness will increase by a factor of 9. There is one more important concept left to discuss in this section, and that is called the time period of vibrations. Time taken by an object to complete one oscillation is called its time period. If an object completes one oscillation in 1 millisecond, its time period is 1 millisecond. If it completes one oscillation in 10 milliseconds, its time period is 10 milliseconds. Let us review all the concepts that we have studied today. We talked about frequency, which is nothing but the number of vibrations per second when an object is set into vibratory motion. It determines the pitch. Amplitude is the maximum distance covered by a body from its mean position when set into vibratory motion. And the time period is the time taken by an object to complete one oscillation or vibration.